Okay, so when we look at problem 4, notice it has an x-intercept right there at -2. And it has another intercept, and actually, see how it just bounces off of 3 there? So this is a double root. In the previous video, I talked about, so that root would have multiplicity of 2 when most roots normally are 1. But this is what we also call a double root. So basically, we have a single root and a double root. So one single plus one double, which counts as 2, means we're most likely have, no guarantee, but most likely have a x cubed function. And so basically, we know that our function y is going to be a times, a is just some number, x plus 2, be careful your signs because -2 would make it 0, and then x minus 3 squared. We need the square power there to represent the double root. Now, if we want to be more precise, we could plug in, it looks like there's a y-intercept at 4.5, so you could say 4.5 equals plugging in 0, right? Because that point right there technically is 0, 4.5, right? 4.5. Now, I don't know if your teacher is going to want you to do that or not. That's what you need to help me with. But I'm going to plug in 0 just to complete the process here. So I know that 4.5 equals, assuming that intercept is 4.5, a times 2 times -3 squared. So 4.5 equals a times 18. So therefore, a is going to be 4.5 divided by 18. And whatever that value is goes in front of a, and then you actually have the equation. But I got a feeling that all you really need to do is set up the x plus 2 and the x minus 3 squared, and that's all your teacher wants. Okay, let's take a look at number 5 here. Okay, so oh geez, I copied down the wrong. Okay, let me get rid of this. Okay, here we go. So we're looking at number 5 now. On number 5, we're supposed to create a sign line. So basically, all you have to do is make a number line. Notice right there, 0 is a root. We know right there that 3 is another root. And right there, we know that -5, 1, 2, 3, 4, 5, is my third root. So we have 3 single roots. So it's going to be a cubic function. But anyways, here's how you do the sign line. We're going to pick a number to the left of -5, let's say like -6 or -7, and just plug it in. And you don't have to figure out the actual value usually, but -6 times x is -6. -6 minus 3 is -9. -6 plus 5 is -1. And a negative times a negative times a negative, that's positive 54, or -54. So we know it's negative here. So let's put in our little borders where our roots are, little dividers. Now we want to pick a point in here between 0 and -5. The first two roots, right? So we can pick any one of these numbers. How about we do -3? And if I plug in -3, just plugging in -3. -3 for x is -3. Negative 3 minus 3 is negative 6. Negative 3 plus 5 is 2. Negative times negative is positive, times 2, which is positive, is positive. So far we have a negative, then a positive. Now, 0 to 3 should be negative again, but you always want to make sure, unless there's a double root, then it could be positive. But let's pick the value 1 and plug it in. So we're going to plug in 1. And so x for 1 means positive 1. 1 minus 3 is negative 2. 1 plus 5 is 6. Right? And that's a negative value. As I was kind of predicting, these should alternate on most regular functions. Negative, positive, negative. So let's pick a value like 5 to the right of our final root 3. And it should be positive, unless, again, there's a double root at 3 or something. Okay, so we're going to plug in 5. So notice x for 5 means 5. 5 minus 3 is 2. 5 plus 5 is 10. So that's, what, positive 100, but it's definitely positive. So right there is your sign line. Now, what's just as important is what you do with a sign line, like in the previous problem. I know that if I have a root at negative 5, 0, and 3, negative 5, 0, and positive 3, those are my 3 single roots, right? There are 3 single x-intercepts. What do we know with the sign line? To the left of negative 5 is negative. So we know it's going to be down here somewhere. We know between 0 and negative 5 is positive. So we know it goes up here somehow back to 0. From 0 to 3 it's negative. So we know it's going to be below here, going back to positive 3, which is a 0. And then when we're right of 3, it's positive, so we know it goes up again. And there we have our typical x cube function here. And remember from the other problem, we know it's got to be y equals some number a times, I'm doing more than they asked, but just to make sure you tie it all together. So we would say x plus 5, because that's what makes negative 5, 0, times x times, oh, wait a minute, I'm getting ahead of myself. They gave us the actual function. So we know a is 1. All right, I've done too much. That's it.